Nvidia's AI Developers Conference is underway. CEO Jensen Huang unveiling the next generation of AI chip.
This particular platform, the Blackwell, is very important because of the efficiency and how much power processing it can provide.
Nvidia just launched a new computer that could change the tech world. This bold move signals a possible power shift to Microsoft. Nvidia's latest AI chip is sparking talks of a serious rivalry that could alter the future for big tech companies like Microsoft. With Nvidia's value quickly doubling, all eyes are on what happens next. Could this start a major tech battle? Join us to see what this fierce competition means for the future. Will Microsoft step up, or are we seeing signs of trouble ahead? A new dawn in the AI era. In just 8 months, Nvidia's market value skyrocketed from $1 trillion to $2 trillion, driven by the growing need for its products that are essential for AI advancements. In March 2022, Nvidia introduced the Hopper architecture, which significantly enhanced AI accelerators used in data centers. This development created a buzz within the AI community. Throughout 2023, as AI applications became more widespread, demand for Nvidia's technology surged, leading to long wait times, up to a year, for their H100-based servers. By the third quarter of 2023, Nvidia had sold an impressive 500,000 units of its Hopper-based H100 accelerators, strengthening its position in the market. Riding on this success, Nvidia launched the Blackwell architecture, named after David Blackwell, an American mathematician whose work has greatly influenced AI design and training methods. But this wasn't the only game-changing move. In October 2023, during an investor presentation, Nvidia revealed its latest advancements in data center technology, introducing the B100 and B40 accelerators based on the new Blackwell architecture. The switch to Blackwell, which was earlier known as Hopper Next, was officially announced at the Graphics Technology Conference in March 2024. Held at the San Jose Pro Hockey Arena, the event drew over 11,000 attendees, including software developers, tech leaders, and investors. At this conference, Nvidia's CEO, Jensen Huang, explained that Blackwell is more than just a faster chip. It's a complete platform that goes beyond traditional GPU production standards. Blackwell combines 2 chips into one, operating at incredible speeds and efficiently managing data with no memory or cache issues. However, this wasn't the biggest breakthrough. Despite some doubts about its ambitious goals, Nvidia has achieved remarkable success with this new chip. Blackwell is designed to work seamlessly with Hopper, making upgrades easy and showcasing powerful capabilities. A prototype board demonstrated this by linking 2 Blackwell chips and 4 Blackwell dies to a Grace CPU through extremely fast connections, marking a significant jump in computing power. Nvidia also made strides with its 5th-generation NVLink in the new Transformer engine, which doubles the speed of Hopper and includes computation directly within the network. This innovation allows multiple GPUs to share and synchronize data more effectively, greatly boosting overall performance. Although its rated speed is 1.8 terabytes per second, the actual performance is much higher, far surpassing Hopper's speeds. The new format, known as FP6, improves training performance by 2.5 times per chip, setting a new benchmark in computing technology. But this wasn't the final twist in the tale. Nvidia's advancements signal a new era in the tech world, one that could potentially alter the balance of power among the biggest names in technology. The introduction of FP4 has greatly increased the speed of inference tasks, doubling the throughput. This is important because it helps save energy, reduces network usage, and improves time management, key factors for advancing generative AI technologies. Nvidia has named this time the generative AI era, a significant shift in computing technology. At the heart of this change is Nvidia's new processor that uses the FP4 format, which is crucial for creating content tokens. This processor is a central part of the Nvidia Blackwell AI supercomputer, which is 5 times more powerful than the previous Hopper model. Nvidia is already working on an even more powerful GPU that will go beyond the current model's capabilities. The newly introduced NVLink switch, a remarkable piece of Nvidia's engineering, contains 50 billion transistors, almost as many as the entire Hopper chip. With 4 MV links, each capable of transferring data at a stunning rate of 1.8 terabytes per second, all GPUs can run at full power at the same time. But the real impact of this leap in computing power is yet to be fully realized. This shift points to a future where such powerful systems become standard. The journey from the first DGX model to the latest has been one of incredible growth and ambition. Nvidia started with just 170 teraflops of computing power, and now their latest models are expected to reach an astonishing 720 petaflops. They're getting closer to achieving 1 exaflop of processing power in a single machine, which shows Nvidia's ongoing drive for progress. The DGX series represents a compact yet highly powerful AI system that can reach exaflop speeds, something that usually requires much larger setups. It's exceptional at high-performance computing, managing 130 terabytes of data per second with its NVLink backbone, which is more than the total capacity of the internet. Even more impressive is that it does this without needing costly optical components, saving on both expenses and energy. It operates on just 20 kilowatts of power, much less than the 120 kilowatts typically needed for similar systems. Its advanced liquid cooling system keeps the temperature steady at 25 degrees Celsius, ensuring top performance even during heavy use. Nvidia's ongoing innovations in chip technology are setting new standards in the AI industry. But the complexity doesn't stop with the GPU. Today's GPUs are incredibly sophisticated, with over 600,000 parts and weighing as much as a large car. These GPUs are designed for tough computational tasks, like training advanced AI models with trillions of parameters. As Nvidia strides forward, the technological landscape braces for a seismic shift, setting the stage for the next chapter in AI innovation, Nvidia's journey through innovation. What used to take months and a lot of energy now only takes 90 days with 8,000 GPUs, thanks to the Hopper architecture. And with the new Blackwell architecture, these tasks can be done with just 2,000 GPUs and much less power, just 4 megawatts. This highlights Nvidia's commitment to not just improving, but completely transforming AI computing. As Nvidia continues to reshape the tech world, they're also expanding into robotics, creating systems that allow AI to interact with the real world. They are developing tools like DGX for training AI models and AGX for managing fast sensor data. Nvidia's Omniverse, hosted on Azure Cloud, simulates automated environments where humans and robots work together efficiently. Additionally, the company is bringing its technology into the automotive industry, with its Thor technology set to be featured in vehicles from brands like Mercedes and JLR. But this is just the beginning. Nvidia's advancements are paving the way for even more groundbreaking developments in the near future. BYD is making big strides in robotics, possibly leading to the creation of humanoid robots. Their key project, called Project Groot, focuses on teaching these robots to understand and follow human instructions. They do this using Isaac Lab, a smart learning platform that trains the robots through Omniverse Isaac Sim, a detailed simulation tool. Isaac Lab uses Nvidia's Osmo service to run tasks on powerful systems, making sure the robots get smooth and effective training. Thanks to this setup, Project Groot helps robots quickly learn human behaviors, improving their ability to perform a wide range of tasks, from simple gestures like giving high fives to more complex activities. This is all powered by Nvidia's advanced Jetson Thor chips. As humanoid robots keep getting better, Project Groot is leading the way in a new era of AI-driven robotics. Nvidia's focus on developing top-notch software and technology is setting the foundation for a future where robots play a major role in our daily lives, changing how industries operate and how we interact with technology. This progress highlights Nvidia's role as a key player in the tech world, constantly pushing the limits of what robotics and AI can achieve. But the journey didn't start here. Back in the early 1990s, technology was much simpler. 3 engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, had a vision to boost computers' power, especially for 3D graphics. They met regularly at a local Denny's to brainstorm and came up with the idea of the Graphics Processing Unit, GPU. This device works alongside the computer's main processor to handle graphics, greatly improving how computers display complex images. This innovation marked the beginning of Nvidia's rise as a leading tech company. At first, they focused on the gaming market, which they saw as full of potential. They started Nvidia in 1993 in a small condo in Fremont, California. The name Nvidia is a mix of NV for next version and Nvidia, the Latin word for envy. The green logo symbolized the envy they wanted to spark with their powerful computing tools. Under Jensen Huang's leadership, who had deep technical expertise, Nvidia was set for groundbreaking developments. Nvidia's GPUs transformed personal computers, making it easier to handle advanced graphics. This was a game changer not only for gaming, but also for video production, scientific research, and professional design. Nvidia's constant innovation helped them build a strong reputation for pushing technology forward and boosting computer performance. The founders' goal of creating a specialized graphics chip resonated with the growing needs of computer users around the world, showing their forward-thinking mindset. But starting a company wasn't easy. In the bustling early 1990s, as technology was rapidly evolving, Nvidia was just getting off the ground. Jensen Huang, Chris Malachowski, and Curtis Preem, who had previously worked at big tech firms like HP, Sun Microsystems, and IBM, decided to take on this new challenge. However, starting a company was a different and more complex task than the technical problems they were used to solving. In 1993, with just $200, the founders realized they needed a solid business plan. Jensen Huang made a bold decision to invest his limited funds to officially launch Nvidia, securing a significant ownership stake. This wasn't just about starting a business, it was a calculated risk in a highly competitive industry. But this was only the beginning of their challenges. The next big hurdle was securing investors. They needed to do more than just present a promising idea. They had to convince potential investors that they had what it takes to succeed. Their early attempts to secure funding were met with many rejections. In a market crowded with 89 other hopeful companies, standing out was tough. However, Huang's previous connection with LSI Logic gave them a small advantage, which they leveraged to gain support. In the beginning, getting Sequoia Capital interested in Nvidia wasn't easy. They were unsure about the potential of this new tech company. But after some hesitation, they decided to invest $20 million. With this support, Nvidia created its first product, the NV1, which was released in 1995. The NV1 was unique because it used a quad-based rendering technique instead of the more common triangle-based method. While Sega, a big name in gaming, preferred the traditional triangle method, Nvidia stuck to their innovative quad-based approach. They believed this method would improve game graphics and lessen the strain on computer processors, which was crucial when computing power was limited. Nvidia's innovative strategy didn't just influence gaming, but also paved the way for advancements in robotics and autonomous vehicles. By using quadrangles, Nvidia aimed to make game graphics smoother and more efficient for the technology available at the time. Additionally, the NV1 had a special feature. It allowed users to play popular Sega Saturn games on their PCs, blending console and PC gaming. But the NV1 had its problems. It was complicated and expensive compared to its competitors. It also struggled to keep up with new standards like Microsoft's DirectX, which focused on simpler triangle-based rendering for graphics development. Despite these challenges, Nvidia kept pushing forward. They went public in 1999, and their market value quickly reached $600 million. This success showed that their early risks and strategic choices were paying off. Nvidia's journey was a testament to their resilience and innovative spirit, proving they could handle both technical and financial challenges, securing their place in the tech world. With each technological stride, Nvidia carves a deeper path into the future, promising more groundbreaking advancements to come. Nvidia's path from financial crisis to market dominance. However, The NV1 project taught Nvidia some hard lessons. The product tried to do too much, combining 3D graphics, video, and audio processing into one chip. This overreach resulted in a product that didn't meet the market's need for simpler, more focused devices. As more developers began to prefer the simplicity of DirectX, the NV1's flaws became more apparent, reminding Nvidia of the importance of aligning with market trends. The NV1's issues caused significant financial trouble for Nvidia. One of their major clients, Diamond Multimedia, returned nearly all 250,000 units they had purchased, pushing Nvidia to the edge of bankruptcy. The company had to lay off almost half of its employees, leading to a $10 million loss. Around the same time, Nvidia faced similar design problems with their next chip, the NV2, developed for Sega. In this tough situation, Nvidia's CEO, Jensen Huang, made a bold move. He asked Sega's CEO to cancel their NV2 contract, but let Nvidia keep the payments already made. Surprisingly, Sega agreed, giving Nvidia the financial lifeline they desperately needed to stay afloat. This experience with the NV1 taught Nvidia crucial lessons about the importance of listening to customer feedback and following industry standards. They realized how vital it was to align their products with what the market wanted. After rethinking their strategy, Nvidia focused on simplicity and market alignment in their future products, a shift that played a key role in their comeback and eventual success in the PC graphics industry. Nvidia's journey from struggles to major success shows how persistence and adaptability can help overcome challenges. In the late 1990s, Nvidia didn't just bounce back. They made a strong comeback into the personal computer market with a clear plan. By 1999, a year when home computers were becoming more common, Nvidia introduced the GeForce 256 graphics card. This was the first card with programmable graphics, marking the birth of the GPU, graphics processing unit. This innovation greatly improved video game graphics, allowing for more detailed visual effects like shading and lighting, and it changed the gaming world. Using this new technology, Nvidia went public the same year, establishing their presence in the market. By 2000, they landed a significant $200 million deal with Microsoft to create graphics hardware for the upcoming Xbox console. This deal was a major step up from their earlier work with Sega and helped strengthen their financial position while securing their place in the gaming industry. When the Xbox was released in 2001, it featured Nvidia's NV2A chip, and the console became a big success. As the 2000s progressed, Nvidia expanded its reach beyond gaming consoles, becoming a key hardware supplier for big tech companies like Apple, Dell, and HP. By integrating Nvidia's GPUs into various devices, these partnerships fueled Nvidia's rapid growth, helping them become a leading name in the tech industry. One of Nvidia's smartest moves was operating as a fabless chip company, meaning they focused on designing chips while outsourcing production to Taiwan's Semiconductor Manufacturing Company, TSMC. This partnership, which lasted over 3 decades, was essential. TSMC did more than just make the chips. They helped bring Nvidia's advanced designs to life. By concentrating on design and innovation, Nvidia ventured into new areas beyond traditional gaming and graphics. In 2006, Nvidia introduced CUDA, a toolkit that changed the game in parallel computing. Before CUDA, programming GPUs was a complicated task. CUDA made it easier, allowing developers to use familiar programming languages to tap into the power of GPUs. This opened up new uses for GPUs beyond just graphics, in fields like medical research and engineering. CUDA was a significant step in Nvidia's strategic vision and had a huge impact on the tech industry's growth. By 2008, the Tokyo Institute of Technology was using CUDA-powered GPUs in their supercomputer, showing just how powerful these tools could be. This was not just a technical achievement, but also highlighted Nvidia's growing influence on the future of technology. Over time, the role of GPUs became even more important, finding use in cloud computing, machine learning, and video streaming. Major companies like Amazon Web Services, Google Cloud Platform, and Netflix quickly adopted these GPUs to improve their technologies. In 2012, Nvidia hit a major milestone in artificial intelligence with the creation of AlexNet, a deep learning network developed by PhD student Alex Krzyzewski. He used two Nvidia GeForce GTX 580 gaming cards to process 1.2 million images, reducing the error rate in image recognition from 25% to 15%. While these numbers might seem small today, they were revolutionary at the time and changed how people viewed neural networks, which had been doubted before. This achievement was not just a technical victory, it marked the beginning of a new era of AI tools we use today, like ChatGPT and Google Lens. The role of Nvidia's GeForce GTX 580 cards in this breakthrough was critical. Nvidia designed its graphics processing units, GPUs, specifically for CUDA technology, making them ideal for handling multiple tasks at once, which is crucial for deep learning projects like AlexNet. This innovation opened up new possibilities in deep learning, putting Nvidia at the forefront of this technological shift. Their focus on CUDA and related software proved to be a smart move. As technology advanced towards more complex AI and large-scale language models, Nvidia's GPUs became the preferred choice. When ChatGPT was launched in November 2022, demand for Nvidia's A100 series GPUs skyrocketed, with major tech companies rushing to buy these powerful chips. Microsoft alone purchased 10,000 units, each costing $110,000. Despite the high price, Nvidia sold hundreds of thousands of units, boosting their revenue to $13.5 billion by July 2023, double what they earned the previous year. On May 25, 2023, Nvidia's market value saw a huge jump, increasing by $184 billion in just one day. Shortly after, on May 30, 2023, the company reached a significant milestone, achieving a valuation of $1 trillion and then surpassing $2 trillion. This achievement placed Nvidia among the world's most valuable companies. Is Nvidia's rise a threat to the stability of the tech industry or a necessary evolution? Let us know your thoughts in the comments below, and don't forget to like and subscribe for more.